All right, guys, welcome back. In this chapter, we're going to talk about fallback functions and the low-level .call functions. So let's start with the fallback functions. What exactly are the fallback functions? In Solidity, we have something called a fallback function, which is exactly what the name says, a fallback. When someone tries to call a function that does not exist or could not be found, this function would be called, and it is essentially a catch function or the backup function. So before Solidity 0.6 came along, developers would use the fallback function to handle logic in two scenarios. Number one, when a contract receives ether without any data. So if someone calls a contract with some ether sent to it and did not pass along any data, this fallback function would fire and developers can use it to handle that situation. And also when people send data with or without ether. In those two scenarios, the fallback function would be used. And there are multiple applications of both scenarios that actually are quite beyond the scope of this introductory class that I would not go in details. But let's just say there are applications for both cases. We're dealing with Solidity 0.7. So now the rules are a little different. Now, actually, there are two kinds of fallback functions. There's a receive function and there is a fallback function. So the responsibilities are split between the two. For the first scenario, for the scenario where a contract receives ether and no data after 0.6x, which is definitely true for our case because we're using Solidity 0.7, receive function is actually called or used mainly. And in this case, the fallback function is called, and these functions are pretty much without any names. They're unnamed functions. So let's see the difference between the receive function and this fallback function, these unnamed functions. So let's say someone just called our function with a low-level message, and they did not pass any data. So the first place our smart contract would go to is the receive function. This receive function is implicitly payable. It has to be payable because a call without data, and also it's a call with ether. This will be the first function that it will fall back to. There can only be one receive function in a contract, and the syntax for a receive function would look something like this: receive, external, and payable. So it can be called from outside and it has to be payable. That's one of the main requirements of a receive function. You cannot skip the keyword payable. On the other hand, if the function is called with data, with or without ether, the first function that it will fall back to is the fallback function. And this fallback function may or may not be payable. You may or may not have to use this keyword payable. And this is normally used in proxy patterns and upgradable contracts. And that's what I was referring to a few minutes ago. That I cannot really cover that in this class. And that's beyond the scope of this introductory class on Solidity. Maybe I will make another class about it, but this is not the class for it. Just know that fallback function is mainly used in proxy patterns. And the syntax of this fallback function would look something like this. It's an unnamed function, external and payable. While I cannot go over the application of the fallback function, the new fallback function, I can actually show you how receive works. And we can modify our already existing parking lot contract to use receive. And we can just dive deeper into how it actually works. All right, so let's get started. Let's open up Remix. And as you can see, we have this old parking lot, parking spot, and ownable contracts. And let's make some changes to the parking spot contract. So the parking spot contract has this park function, which takes in some ether, and then it turns the lot status to full. While this is good, I want to make some changes. Instead of using this park function, I want to use the receive function. But mind you, this is probably not the best way of going about it. What we have here, park function, is probably better. I just wanted to show you how receive actually works. And that's the only reason I'm doing it. This is not an upgrade. This is actually another way of doing things, which not necessarily is the best way. So let's just comment out this code. We don't need this anymore. And let's write our receive function. So receive function does not need any name. Receive is the receive function. It has to be external. It has to be payable. Don't forget that. And that's the function signature. The first thing this function would do is basically what the other function did, park function. It will make the lot status full so no one else can park in this parking spot. It will also transfer money to the owner of the parking spot. And it will also emit an event that someone has parked in this parking spot. And also this receive function will be just like the park function. So it will work when someone has passed in 10 ether or the spot itself was empty. So we use the same modifiers. Now to use this in our parking lot, we have to make some changes here. Actually, let me show you why we have to make the changes. As we have already tested, everything deployed correctly and well, everything we could compile correctly and deploy properly. Now there will be some errors if we try to compile it. So let's take a look at those errors. Okay, here are the errors. The number one error it's saying is explicit type conversion not allowed from non-payable address to contract parking spot. So because this parking spot contract has actually now received function, which is payable, so we cannot do this. Even though we are not passing any ether into it, Solidity will stop you from using this. One way to get around it is actually changing this address, which is spot ID, to uint 160, so 160 bytes, which is the amount of storage needed for an address, and then change it back to address, thereby tricking the Solidity compiler. This is not what you should do in real life, but I'm just showing you that this is one of the things that can be done. So let's say uint 160 bytes. So we change this address to integers first, and then back to address. And now if we try to compile this, that error goes away. But this thing, we will have to do the same thing here as well. And also here, but I'll do something special here, so bear with me. So this one is saying the same error. The second error, line 22, is actually saying the park function cannot be found, which is true because we just did out the park function. So this parking lot function should just call the parking spot function without any data and give some ether, and that will trigger this receive function. So how do we do that? So one way of doing that is using .call low-level Solidity function, where we can actually say what data to send, how much value to send on a different contract. So let's try that. And for doing that, we don't really need a reference to this parking spot contract. We just need the address. So this is the address of the spot ID, and then wrap that in parentheses, and then we'll call. So we are calling this address, and we are passing in the message.value, whatever amount of ether that was sent to this take-up spot function. And also, as we have already discussed, the receive function gets triggered whenever no data is passed. So to say that no data is passed, we can just use this with an empty string, and that means on this address, call to a dot level call with this value and no data. That's what this means. Another thing that I want to discuss is about error propagation. So whenever we were calling this park method, which we would no longer use, so we just comment it out. Whenever we were using this park function, which was being called on the spot contract, whatever error that was being thrown on this park function was getting bubbled up to this contract, and it would revert. That is not the case whenever we use a very low-level function call like .call. So we have to handle the error propagation ourselves. So let's do that and see how we can do it. So whenever there is a .call function, it returns a bunch of values. And the first property, the first parameter of the return data is actually a Boolean that says this low-level function called succeeded or failed. So let's get that data out. We can just call it full success. So this just data out that gets the first parameter of whatever was sent back from this .call function. And just delete this. Don't need the park function anymore. We're just calling the contract directly and passing in message.value. And then we can say if there is no success, so if success is actually false, then we will throw our own error using the revert call keyword, line call to contract failed. So this is why I was saying that this may not be the best way. This is one of the reasons. First of all, we're making the things way more complicated and not easy to read. On top of that, the function errors don't get propagated up. So you lose what was the reason why the function failed in the first place. Instead, we have to throw our own error like this. And there we are losing some data. So we're checking the success Boolean. Now let's see if we can actually compile this. The compilation fails, right? That's because we don't. Oh, this works. And now if we go back to the parking spot contract, we have this receive function, which also works. It also got compiled without any errors. So now let's try and deploy this. So we will deploy this from the C4 address, in the address ending with C4. Cool. That's the owner now. Just double check. Yeah, that's the owner. And let's create some spots. Spot with ID 1, spot with ID 2, spot with ID 3, and each of the spots should have very unique addresses 2, 3. And spot 4 is not deployed, so it should be no address. Cool. Now let's try to use this receive function, trigger the receive function by trying to park our car in spot 3. And to trigger this function, we will actually have to send in more than 12 ethers right here, because it's also checking cost. It's just exactly like before. And we take up spot 3. See, the function transaction went through without any errors, and the spot 3 should be false. Spot 1 and 2 still should be true. Let's see what happens if we actually try and send below 10 ethers. Let's say 2 ethers, spot 2. This should actually fail because this Boolean success returned would be false, and then this would trigger this revert assignment here. Let's try that. So take up spot 2, 2 ether. There we go. It failed, and it actually gave you this message, the error message, underlying call to spot contract failed, which is exactly this. Okay, so the parking spot status of 2 still should be true because this part never got run. This line 55 never got executed. Okay, so let's go back to our parking lot 3 and let's see if we can still revert back. This is the function call we would be using. See, the transaction went through, and if I check the status of parking lot 3, it should be back to true. So there you go. This was an example of how to use this underlying .call low-level functions to call another contract, pass in value and data or no data. And we also looked at how to use receive function. And again, this is not an upgrade to what we had before. I would argue that what we had before was better than this. This is just another way of doing it. And I just wanted to show you how receive and underlying .call functions worked. Thank you, and I'll see you in the next chapter.